It begins with a child's sense of wonder, asking questions, discovering new ideas, organizing them, playing with them. Through this process, we open our eyes to the world around us. We open our minds to the pleasure of finding things out. We call this science.
Hi, I'm Debbie Spencer.
And I'm Bill Metz.
And we'd like to welcome you to SBS. SBS is Science by Satellite, and you're taking part in a real big experiment right now, guys. But it's an experiment in teacher development.
We'd also like to say hello to our other teacher groups and their sponsoring museums. Here in the studio, we're being sponsored by the Franklin Institute. In Atlanta, it's the Fernbank Museum. In Miami, the Miami Museum of Science. And in Eagan, Minnesota, the Science Museum of Minnesota.
Now, you've just watched us do a simple, everyday task. Every person in America probably has done this at some time or another. But when did you ever stop to think about what was really going on? Is there any more to it?
You bet. There's a lot more. Our theme today is energy, and we will be looking at energy sources, energy receivers, and the evidence of energy transfer. For example, our teapot system. What do you think? What do you think the energy source was? What about the energy receiver?
Wait a minute, Bill.
What?
They can't answer any questions.
I messed
Nobody
up.
can tell you anything. They've got to learn how to use this thing first. He's screwed up. Don't pay no attention to him.
Let me explain how your one-touch system works. Each downlink site has 10 one-touch keypads. When you want to speak to us, press your call button. When you do, the red wait light will come on. When the green speak light comes on, you're on the air. Just speak normally from your seated position. You don't have to talk right into the mic. When you're done speaking, we'll turn off the microphone from here. By the way, if you change your mind about speaking to us after you've pressed the call button, just press it again, and it will cancel out. Okay, it's practice time. I'm going to ask you some questions, and we'll give you some time to think. The questions are, in our system, what are the energy sources, what are the energy receivers, if there are more than one, and what is your evidence of energy transfer? We'll be back in just a minute. Okay, back to you. We're going to ask you some questions now. Please respond by using your one-touch system. What is the energy source in our system? Okay, let's ask somebody at the table.
Somebody in here.
Anybody here? What's the energy source?
Hot plate.
Would you say that a little louder, please?
Hot plate.
The hot plate. All right. Minnesota, we understand you've made a call here. What's the energy source?
We agree that it's the hot plate.
Ah, that's a cop-out.
You're not going to go out on a limb.
What in the hot plate do you think is causing that energy?
Yeah. Well, it starts with the sun, then fossil fuels, and then...
Okay.
What else? You guys are having a lot of fun at my expense here. Come on.
I would say more directly the heating element in the hot gas.
Okay. Let me give you a little hint. All right, Miami, we understand you have a question.
Oh, we were saying that we didn't know whether it was electrical or whether it was a gas hot plate.
Okay, you've got gas.
Need more information.
I've got gas.
We can't hear you now.
Okay, we've got an energy source. What about the energy receiver?
The receiver is coming through the air up into the metal of the pot.
Okay. And how do we know that that energy's been transferred?
Okay, we have the evidence of the change of phase of the water.
Ooh, nice words.
Oh, yeah. I
All
like that.
right. Not too bad. All right, we've gotten some good responses, and we've had some fun learning about this teapot system. We'd like to. Where are we going from here, Debbie?
We're going to
the observations.
We're going to go to my class. Bill.
Okay. Debbie ran this with her children at her school. I'd like you to look at this videotape, and let's see how your observations compare with these children.
We talked yesterday about energy and different types of energy, and all we're going to do right now is just take the time to watch something that you've probably watched all the time. But this time, instead of just, we're going to watch it, but we're also just going to think about it. And I want to get some ideas from you as to what you see happening. Now what I have here, this is just it's a portable burner. This comes, see, it's portable. You can pick it up and you can carry this with you. It's just a portable burner. What kind of energy is this? If this is just a gas, something in a can, what kind of energy would that be? Good, it's chemical energy. And I'm using this chemical energy. Now watch what happens. See what happened? You see the flame? What kinds of energy do you see now? Jordan? Okay, heat energy. What other kind of energy? Shalana?
Light energy.
Light energy. Now that the tea kettle is on the flame, what's going to happen to the tea kettle? Joanna?
It's hot.
Because what's hot?
The metal.
Because the metal is hot. That's called a transfer. There's your heat, and it's going to the metal. And then this is going to get hot. And it's just transferring the heat over. Now, the heat from the metal, what's going to happen next?
It'll probably boil in the teapot.
It will boil, or
Steam builds up so much it just bursts out into the little hole.
bursts out into the little hole, and what happens?
It whistles because it goes so fast.
It whistles. So what kind of energy would that be once it starts to whistle? Ian?
Sound energy.
Sound energy. We went from chemical energy to Alexis?
Heat energy.
Heat energy. What kind of energy would I be using if I poured myself a cup of hot water and put a tea bag in it? Jordan?
Chemical energy.
It's chemical energy. Now it's whistling. Now what kind of energy is that? Kaylin?
Sound energy.
That's right, it's sound energy. Let's go back and retrace our steps for a second. Just put your hands down and think about this. What kind of energy did you start with? Just think. What did you start with? And this went to a certain type of energy, and that went to here. What was inside? To this, to a mug. There's a lot more happening in that teapot than meets the eye. There's a lot of things happening in there. And it's sometimes interesting to take something as simple as that teapot and think about how we got to that bird whistling over there.
It's interesting to me to listen to what the children said and now listen back and look back to what you said. Your observations are basically the same. It's just the communication of those observations that's different. I want you to take a look at this.
Making these kinds of observations is the first step toward using energy. Heating water into steam causes it to expand to 1,000 times its liquid volume. The resulting pressure can be used to do useful work, pushing on pistons, moving freight and people on a large scale or a small scale. Ha! Energy sources. Well, wait a minute. Hold on. Bruce, you may want to move just a tad. We get in real big trouble
We get dangerous around here
if we kill
sometimes.
some of the participants here. All right, we've got an energy source. And wait a minute. Every time I start that, when this one goes. So we've got some energy sources, but we've also got some energy receivers here. And that's what we're going to be looking at again throughout this show. Please try to keep these points in mind. Energy source, energy receiver, and the evidence of energy transfer.
Okay, for instance, I've just got a small spool car here. There's a spool, a rubber band, and a toothpick. Source, receiver, please do it, and evidence of transfer. Yes!
That's nice,
did it.
Debbie.
Oh, I like
No, this is tool
No.
time. We need more power. No, this
I
is.
like my little car.
We want monster cars.
Oh! I like
Small
that.
may be fine, but bigger is better.
Yes!
This is a bottle racer. The components of this are cheap and recyclable. That's the neat part. Our first activity, we're going to build one. I'll show you how, and then we'll build one together. Here is a list of the contents of your kit. Your coat hanger has been pre-cut and pre-bent for your convenience. 1/4-inch holes have been pre-drilled in the bottle caps. A larger hole has been placed in the bottom of one of the bottles. The larger hole will permit you to feed the large rubber bands through. The second bottle has been sliced to expedite completing the cutting process with scissors. This is also an important safety consideration when working with children. Leaving about 3 to 4 centimeters beyond the curve will be helpful when attaching and aligning the bottles. Connecting the 2 rubber bands is the next step. Now, straighten the coat hanger and use the small hook to help pull the rubber bands through the hole in the bottom of the bottle. Secure the loose end of the rubber band with a small piece of stiff wire. You will want to tape this piece of wire to the bottom of the bottle. Attach the cap to the top of the bottle and bend the wire at a 90-degree angle. This will hold it in place. Now take the section of bottle that you cut and force it on the bottom of the uncut bottle. The next thing you'll need to do is hold it in place with a large rubber band or tire. You can also add another tire to the other end to balance the system. Bend the loose end of the coat hanger at a 90-degree angle and place it in the remaining bottle cap. Bend the coat hanger in from both ends to create a slight inward tension. This will help keep the coat hanger in place. And voila, a finished product. Okay, we're about to start. If you have any problems, please don't
call
hesitate
us.
to call.
We'll be here, so you can call us with whatever you think it is.
Now, while you're building this, we're going to give you some challenge questions. After you have this thing working, and you probably will get it without too many problems, try to identify the variables that you think will affect the distance as well as the direction.
Now, you'll have about 15 minutes to do this. So we'll be back with you in about 15.
Yep, we're going to go work with our
Okay,
groups. See you
bye-bye.
later. Okay, satellite downlink stations. We've got not a problem, but a little bit of help for you. We found that if we straighten the coat hanger out considerably and thread our rubber bands through this way, it makes it much easier to get everything set up. But be sure you have that little piece to hold the rubber band on the bottom. All right? If you have problems or concerns, or you find an easier way to do things, call us, please. Okay? Well, how'd you make out? Let's take a look at some of the questions that we raised in the very beginning. What did you find was the main variable in the distance that your spool car would go? I hear some noises out there.
We hear somebody, but they're kind of disembodied right now. Oh,
Okay.
Spinning the rubber bands.
All right, spinning the rubber band. Amber?
It was the way you had your coat hanger bent.
Tom, could I go over to that camera? Sure. All right. Okay, Amber just said that it was the way in which the coat hanger was bent. Could you explain that a little bit more?
Well, when we first did ours, our coat hanger was kind of crooked, and it was on a tilt, and we found that our bottle would only go in a circle. So then we had to straighten it out. My life is like that, no, but we had to straighten it out, and then we found that we could go straight, and we could get more distance that way.
All right. Anybody out there at the other sites, did you have any problems? I hear voices again. Atlanta, yes.
We'll be right there.
Okay.
Bill, we also found that when Brian and I ran our little spool, that it curved to the right. And what
Yes.
we did is we changed the position of the rubber bands. And when we did that and evened them out, it continued to go straight.
All right. Okay, Egan, go ahead.
The rubber band keeps getting caught at the end where it's hooked with the hook of the coat hanger.
Okay, up
On that end.
up in this area.
Pardon?
Up in this area.
Area.
were you able to fix it?
Not yet.
All right. Suggestion to you. We did this with children. You're about to see that. One of the biggest problems with this is that there is a great deal of friction created at this end. But we don't tell the kids that. We let them figure that out for themselves. It is a nice lesson on friction as well as simple machines. Did you, aside from the spinning aspect and the turning aspect and the friction, did anybody else have a problem?
How come it went backwards sometimes?
How come it went backwards?
Oh.
Okay, Bluebell.
Bluebell, you have a question.
Hi, Bell Pedal School District of Philadelphia. My rubber band broke.
Well,
Ask Marty from Bluebell. He'll help you.
Marty is the rubber band king here. Either that or borrow some from somebody else.
Steal one.
Yeah, steal one, right. Teachers are good at that. Did anybody have one go backwards? We had one go backwards here.
We just flipped the hanger over and it went the other way, and then it goes
All
forward.
right.
Well, they had to change gears, yeah.
All right.
Goes along with the broken rubber band.
All right,
I
Bluebell.
can't hear you. My rubber band broke. I got no response.
Okay. If you need another rubber band, there is a gentleman in your area there whose name is Marty. Marty is the rubber band king. All right.
He will help you.
Marty will get you a rubber band. Marty's not there anymore. Then steal one from someone else. That's the only other alternative.
Just raise your hand. Someone will get you a rubber band.
As a teacher note, these rubber bands, this is a number 105 rubber band. And the biggest ones that I've found commercially are number 84s. In your teacher guide, there should be an address where you can get these. And I don't know. The 84s work, but they're not as large. You have to use 3 in the center rather than 2.
I have a question.
Yes.
If you put a little weight in the bottle, not enough to slow it down, but do you think that would help it to keep it on the floor, because it did keep popping up off the floor a little bit because it's so light?
Okay. That's an option.
Try.
You might also try some things on when you see the video that's going to be coming up soon. You'll see that kids in my school did some creative engineering.
Wheel back here.
Well, yeah, you wait. You know, they had everybody but their little brother back there. But they had some interesting things going on. All right, let's go back to home base here, and we'll see what else we can get done here. Okay, would you roll the teleprompter up a little bit? There we go.
Thank you. All right, what you need to think about again, I'm sure you had a ball with these things, but our theme today is energy, and we've talked about energy source, energy receiver, and evidence of transfer. So as you're looking at your bottle, think about where those places are, or where those points are on your bottle racer. Now, if you think you had some fun.
Yeah. Let me show you what a 5th grade class in my school experienced.
Sarah! What? Come on, jump with
Let's make things a little bit more difficult for you this morning. I ask you to bring those bottles in, and we're going to make monster cars, all right, like you have, like Bigfoot. Your Bigfoot's going to be made from a top and a rubber band, a hanger, and that's it. Are you about ready? All right, so let's get started. Tell me about this wheel.
When you put the wheel forward, it makes it go faster.
How do you know that?
Because when I winded it up the same amount of times a little bit ago, like this, it didn't go so fast. And then when I did it, the wheel in front, it went farther.
And you had the same amount of windings.
Yes.
But when it was here, it went further?
Yes.
How much further? All right, now, tell me about your car.
It doesn't go that fast. That's all it really does is spin around like that, like 360.
Does 360s? What have you changed?
Well, I bent these and it goes straight sometimes. When I put this here, it spins around. When I put that in front, it goes straight.
So it makes a difference.
Yeah.
When this does a 360, does it always go in the same direction?
It mattered, like if I spin it this way, it spins that way. If I spin it that way, it spins that way.
Oh, wait a minute. When you spin what? When you turn the rubber band one way, it spins one way, and when you turn the rubber band the other way, it turns the other way. Mm-hmm. That has nothing to do with the shape of the car, or whether this is in the front or the back?
I don't know. I haven't tried that yet.
Let's try that. All right, gentlemen and ladies, start your welcome. Start your engines. 1, 2, 3. Go.
3.
Go. Fantastic. Well, I think you experienced some of the things that my 5th graders experienced. We had a good time with these things. They're great. But this really is only a beginning. And I think you should observe and view every science activity like that. It should begin with a wonder and end with one. Good questions. I wonder what would happen if, I wonder what would happen if you used bigger bottles or smaller bottles, or one big and one small, and maybe more rubber bands. The list is endless. And that's where the real science begins. Just like this toy, so to speak, the problem is with this, you can see inside. And that is a problem, because that eliminates a lot of good thought by kids. Debbie?
It begins with a child's sense of wonder, asking questions, discovering new ideas, organizing them, playing with them. Through this process, we open our eyes to the world around us. We open our minds to the pleasure of finding things out. We call this science. Science.